Hello everyone, thanks for stopping in. Today we're going to be talking about Math sections 3.1 and 3.2 for Math 100. And let's start off with a bunch of definitions. And we're going to be kind of jumping back and forth from top to bottom here. As we define things, we'll be drawing a picture to correspond with them. So first, the Cartesian coordinate system. The Cartesian coordinate system is a set of two perpendicular number lines used to graph points and lines using two variables. It's a set of two perpendicular number lines used to graph points and lines using two variables. Perpendicular, in case you need a reminder, means they meet at 90 degrees, right? So let's draw a Cartesian coordinate system down here. So we'll draw two number lines that are perpendicular to each other. We'll put our arrows on the ends. And then we can maybe label them, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, and 4. Right? And then we can put a little 1, 2, 3, 4 if we want, right? -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, and -4. Notice it goes positive to the right and positive up. The up and down number line works positive up, negative down. Left and right is negative left, positive right. So that's a Cartesian coordinate system. The x-axis is the horizontal number line. We call it the x-axis because we usually use the variable x to represent numbers from that number line. You don't have to use x, but that's the standard letter, right? You could use time if you're talking about a graph that works with time. Then you might use the letter t. Maybe you're talking about cost. You might use the letter c for cost, right? But in general, the phrase is x-axis to talk about the horizontal number line. The y-axis is the vertical number line. So the y-axis is the vertical number line. So the x-axis is the horizontal, the y-axis is the vertical number line. The origin is the intersection point. The intersection point. The origin is right here. Right there, that's the origin. Sometimes people might label it with the letter O for origin. Some people label it with the letter O. Now, quadrants. Notice there's 4 different regions to my graph, right? There's 4 different regions. If I think about these different separations, right? The lines create 4 separate areas. Those are the quad for 4, right? The quadrants. These are the regions which are separated by the axes, right? The axes separate them. They are numbered counterclockwise. And we start in the top right. We start here with the first quadrant. I use the Roman numeral 1 for the first quadrant. It makes sense we start here because this is the positive quadrant for both, right? This is positive here and positive here. The second quadrant is over here because we're going counterclockwise, right? The third quadrant is down here. And the fourth quadrant, remember Roman numerals, fourth is IV, right? So first, second, third, and fourth quadrants. So there's 4 quadrants, first, second, third, fourth. And remember, they go counterclockwise, and you start in the top right. Now, ordered pairs is a list of two numbers, a list of two values, x comma y, that determines a point within the system. It determines a point. So let's create an example. Let's say I wanted to graph the point 3, 2. So the x is 3 and the y is 2. I would go over to 3 on the x, and I'd go up to 2 on the y, and I would find where they meet. 3 and 2 meet right there, right? If I go up from 3 and over from 2, and I would label it 3, 2. The x is first, the y is second. You do x, you go left and right first, then you go up and down when you're working with ordered pairs. Now, the origin is 0, 0 as an ordered pair, right? It's at 0 and 0. You don't go anywhere for the origin. So we can have ordered pairs as well. And this is the Cartesian coordinate system. Some people might call it the XY plane, the real number system. There's lots of different names for it. We'll call it the Cartesian coordinate system, named after the mathematician Descartes who discovered it. Cartesian, Descartes. It comes from his name. And so let's take a look here. Let's plot some points. So let's look at what we can use a Cartesian coordinate system for. It says plot the points A, B, C, D, and E. So I need to plot these 5 points. The first thing I always like to do is get an idea of how big is my graph going to be. What's the biggest value? Let's see. I have -2, 4. Let's see. 3, -2, -1, -3. 6, -4. So it looks like if I go 6 in every direction, right, I will cover all my numbers. So when I draw my axes, I'll draw 6 dashes in every direction, right? Because that will cover the whole spectrum of values I need to consider here. Now, I'm going to say this now. When using the MyLab math program, you will be graphing things in a digital format. It's strongly recommended that you write everything down in paper first. Get an idea on paper before you try to work with the interactive computer display, right? Solve the problem on paper first, then use the computer tools. If you need help, navigating the graphing system on the computer, I will gladly walk through those in the discussion. I'll gladly load up those homework questions and we can walk through those in the discussion. So keep that in mind. I'm going to say that in this video, that you'll be working on paper, right? You'll be doing your scratch work on paper. You'll be solving the problems on the paper, and then you'll be submitting your answers through the MyLab math program. So if you need help with that, make sure you check out the discussion or shoot me an email, right? Make sure you're aware of those little differences, right? Now, let's get back to the question. Let's plot point A, -2, 4. So on the x-axis, I'm going to go to -2, that's left, right? And then I'm going to go up to 4. So -2, 4 would be right about there, and that is going to be A. -2, 4. Left 2, up 4. Now B, 3, -2. The 3 is the x, so I'll go right 3, and then the -2 is the y, which will be down 2. So B would be right there, right? So we have A, we have B. How about C? -1, -3. -1 is the x, so that's left 1. -3 is the y, that'd be down 3. So C would be over here. So we had second quadrant, fourth quadrant, third quadrant. How about D? 6, 0. So I'm going to go right 6 and up and down 0. It's going to fall right on the line. D is not in either quadrant. It's not in the first or the fourth. It's in between them, right? It's on the boundary. So we had second quadrant, fourth quadrant, third quadrant, no quadrant. And then E, 0, -4. 0 tells me to stay where I am, left or right. -4 tells me to go down 4. And that would be E, which once again is not in a quadrant, right? It's on the axis itself. So that's plotting points. What about graphing equations? Notice this equation has a y and an x. Well, the first thing I always like to do when I have an equation is I like to write a little table to help me. And I like to write y equals, I like to write the equation on the right-hand side and x on the left-hand side. Because this will help me graph it. Because I have two variables, right? Now, I'm just going to make up some numbers for x. Maybe I like the number -2, the number 0, and the number 1. Those seem like fun numbers to work with, right? I'm going to make up numbers. I can choose whichever numbers I like. These are nice, easy numbers to work with, right? They're fairly small. I have a negative number. I have a positive number. I have 0. I picked some nice, easy numbers to work with. Now, I picked my x's. I need to find my y's. Well, y is equal to x plus 1, so I'll do -2 plus 1, which is going to give me -1 for the first y. Now, the second y is going to be equal to x plus 1, which will be 0 plus 1, which will be positive 1, right? And then in the last row, x is now 1. Let's see, y is x plus 1, so that'll be 1 plus 1, which gives me 2. So this tells me that -2, -1. Notice I read the x and the y and made a point. Then 0, 1, 0, 1, and finally 1, 2 are all on my graph. When I want to graph this line, if I plot these 3 points, they will give me the graph. So I'm going to draw my axes in. I'm going to get a nice sketch of my line. If I was working in the MyLab program, I would want to sketch the line before I try and input it into the graphing program, before I try and get my answer. I would want to create a sketch, right? Let's see. Maybe I'll go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 in every direction. I'll label x and y. And now I'm going to put these points on my graph. Let's see, -2, -1 will be 2 left, 1 down, right? Right about there. 0, 1 will be nowhere left and right, up 1. And then 1, 2 will be right 1 and up 2, right? And now I'm going to connect my dots with a straight line. I don't have the steadiest hand, but mostly straight, right? And then the last thing I do is I label with the equation I graphed. Y equals x plus 1. That way I know what I graphed, right? And notice I used these 3 points to get my line. To get my equation, to graph my equation, right? Now, I've been using the phrases. Let's look what we have here. We call the above equations a linear equation in 2 variables. It's an equation, it had 2 variables, and it was linear because it drew a line, right? Usually we just say line when the context is clear, right? We just call them lines. I'm graphing a line. Notice how all the points we found can be connected by a single straight line, right? I can connect them with a straight line. Maybe I want to get, post-it notes as a ruler to get myself a little more organized, right? I could have, but I can connect them with a straight line, right? You only need 2 points to make a line, right? If I want to make a line, 2 points makes a line, right? But it is always better to place a third one just to make sure all 3 are on the same line. This helps reduce errors. If I had these 3 dots, there is no way to connect these 3 dots with a single straight line, right? I know one of these dots must be incorrect then, because we're graphing lines. I should be able to connect them with one line, right? So make sure you're graphing 3 points, because that will help reduce errors. It'll help reduce errors. Now, let's graph another one. Let's graph y equals 2x plus 2. Now, same thing. I want to take a table of values right away. And I always like to write y, and I always like to remind myself of the equation. You can just leave the table like this, But I always like to write the equation here so I remember that y is 2x plus 2. You don't need to, but I always like to write it there just to keep myself organized. Now I'm going to pick numbers for x. Maybe I like the number -3. And maybe I like the number -1. Maybe I like the number 2. I'm going to pick numbers that I want to work with, right? I'm going to try these 3 numbers. Now, I picked some x values. What I need to do now is find those corresponding y values. So I'll plug in x. Let's see, it's -3. So I'll do 2 times -3 plus 2. Well, we get -6 plus 2 is -4. So I get -3, -4. Now I'm going to do the same thing, but I'm plugging in -1 now, right? Let's see, I get -2 plus 2. That actually gives me 0, right? And then y equals, I'm going to plug in 2. Let's see, 2 times 2 plus 2, that gives me 6. So I get -3, -4, -1, 0, and 2, 6. So when I go to graph my equation, let's see, it looks like if I go 6, you know, in negative number, that'll cover everything, right? So I'm going to count 6 in every direction. So I'll draw my axes, I'll label them x and y, and then we'll put 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6. We'll put in our axes, and now we're going to sketch our line. Let's see, our first row tells us we need -3, -4. X is -3, y is -4. That'll be somewhere about right there. Next I have -1, 0, -1, and then 0 up or down. And then lastly I have 2, 6, which will be 2 right and up 6. So now I'll use this time to draw a more straight line. I'll take all 3 dots as best I can and connect them with a straight line, right? Oops, I kind of went off my, we'll just put our arrow there. And we'll just scribble that out, right? We're sketching our graph. Now at this point, I now have a sketch of my graph, right? I have a sketch of my line 2x plus 2. Now I want to go to my MyLab math program and type my answer in if this is a homework problem, right? I always want to sketch my graph before I start trying to use the MyLab math program. Always work it out on pen and paper first. Get an idea of what you're trying to create. Now, let's talk about the procedure for graphing a line by plotting points. The first step is create an x, y table. We make this x, y table, right? Step 2, we choose values of x, and I'm going to put in parentheses or y to work with. Step 3, we solve for the corresponding y, and in parentheses I'm going to put x, and I'll explain what I mean by that, values. Notice, when I did this problem, I chose 3 x values. There is nothing stopping me from choosing y values and plugging in y and solving for x, right? For example, maybe I want to use y equals 8. I want to use 8 here for y. I can find the x, right? Because we can do y is 8, so I know 8 is equal to 2x plus 2, which means I can subtract 2 from both sides, right? Subtract 2, which gives me 6 equals 2x. So x will be 3. I can go backwards. That's what the red is telling me, right? That's what the red is telling me. So I'll circle it in red so we know it corresponds. You can choose x values like we did, and then find the y values, or you could choose y values and find the x values. Either direction works. Generally, we like to pick x values because usually our equations are in terms of x. They're already solved for y. And then the fourth step is plot the points and connect them. Connect them. You plot the points and connect them. So first you create an XY table, then you choose values of X to work with, then you solve for the corresponding Y's, then you plot the points. That's what we've been doing here, right? That's what we were doing. Now, let's have a new definition. The x-intercept is the point at which a line intersects the x-axis. In our example here, this value right here, this value right there is my x-intercept. Notice this is the x-axis. Right here, I'm going to circle it. Right here is the x-intercept. That's the x-intercept. Now, the y-intercept is going to say all of the same things, but I'm going to change it to y-axis. It's the point at which a line intersects the y-axis. So the y-intercept is the point at which a line intersects the y-axis. So in my example up here, I didn't actually have the point, but it would be right here. So I'm going to put a dot with my red marker. It would be somewhere right about there, right? That would be the y-intercept. That's where our graph crosses the y-axis. So I've got an x-intercept and a y-intercept. To find said intercepts, if I want to find these, I have an equation, I want to know what values they are. Well, first, to find the x-intercept, we plug in what value is the y variable in the x-intercept. Notice the x-intercept, no matter where I am on the x-axis, I will always be 0 for the y, right? If I'm over here, I've gone up and down 0. If I'm over here, I've gone up and down 0. Here, I've gone up and down 0. So we plug in y equals 0 and solve for x. So for the x-intercept, we're going to have some value in the form of whatever the x is, and I know the y value will be 0. I don't know what value the x will take, right? I have to solve for the x, but I do know the y value will be 0. Now, for the y-intercept, to find the y-intercept, we plug in. And if you're thinking about it carefully, let's see. If I'm on the y-axis, my x value is 0, right? Everywhere on this y-axis, I've gone 0 left or right. I'm just going up or down, right? So we plug in x equals 0 and solve for y. So to find the y-intercept, we plug in x equals 0. So the y-intercept will always have the form 0, y. So we can find each one. Notice they could be the same, right? If the line happens to cross through the origin, right, it hits both axes at the same point, 0, 0. That's the only time these values are the same, right? Every other time there'll be two different values, one on the x-axis and one on the y-axis. But sometimes you might go through the origin and they might actually be the same number, right? You might actually get 0, 0 for both of them. But that's only if your line goes through the origin. So we have one more example. We have the line 2x plus 3y, and we want to graph it using the intercepts. So the first thing I'm going to do is find the x-intercept. So for the x-intercept, I remember that I want to find what's going on when y equals 0. So I'm going to take my equation, 2x plus 3, let's see, y is 0, and that should equal 6. Let's see, 3 times 0, I can figure that out, right? We'll clean that up. 3 times 0 is 0. and that should equal 6. Let's see, 2x plus 0. Well, anything plus 0 is the same thing, right? 10 plus 0 is 10. 17 plus 0 is 17. 2x plus 0 is 2x, right? I'm adding 0. It doesn't change what I started with. And so to get x by itself, I can divide by 2 and get x equals 3. So my x-intercept is 3, comma 0, right? The x value was 3, and the y value is 0. So that's my x-intercept. Now, I also want to find my y-intercept. And remember, for the y-intercept, we'll be doing the same thing, but we plug in x equals 0. So I'm going to do the same thing. 2, now x is 0, plus 3y should equal 6. Same as before, 2 times 0 I can clean up. That gives me 0 plus 3y equals 6. Just like before, 0 plus 3y is just 3y, right? Adding 0 doesn't change the number. And that should equal 6. Divide by 3 gives me y equals 2. So my value here, x was 0 and y was 2. So I have my two intercepts, 3, 0 and 0, 2. So I'm going to draw some axes. I'm going to sketch my line. I'm going to sketch my equation. Let's see, 0, 3, 0, 0, 2. Let's see, so if I go 3, let's make it 4, right? It doesn't hurt to have extra lines. It would only hurt if we didn't have enough, right? So we'll go 4 in each direction. Let's see, 3, comma 0, over 3, up 0. That's the x-intercept. Notice it's on the x-axis, right? The y-intercept is 0, comma 2. That would be up here. And then if I want to connect them, maybe I take my sticky notes here. And let's use the red pen because we were drawing it in red. We draw our line through our dots. And I can label it 2x plus 3y equals 6. So I graphed this line using the intercepts. Notice we now have two techniques for graphing lines. The first was making the table. The second is using these intercepts. Each one has its advantages and disadvantages, so make sure you're practicing both. If a question asks you to use the table method, make sure you make a table. If a question asks you to use the intercepts, make sure you find the intercepts. Make sure you're comfortable with both methods. And that brings us to the end of our section 3.1 and 3.2. I thank you all for joining me, and I will see you next time.